Hello, this video is for IXL Activity 6.Z.5. It is titled Model and Solve Equations Using Algebra Tiles. And our 3-character code for this activity is Golf 6 Zulu, G6Z. All right, algebra tiles. What are they? Well, algebra tiles are, they're what math teachers call manipulatives. That means they're hands-on type things that you could actually put your hands on and use them to learn a math concept. And the pieces have, they represent certain things, such as this green X here. That represents a positive X. And also you could have, do I want to write? Yeah, I think I'll write and use red. So then if you flip this X over, this piece over on the other side, it would be red. And, well, if you're thinking, is that a negative X? Indeed it is. So a green X is a positive X, and a red X, the red side of it, is negative X. And then for the pieces here, kind of interesting that the ones, each of these with a 1, this is a ones unit, right? That's what we call a ones unit. And each of these represent a value of 1. So this would be X, and then we have 1, 2, 3, 4, 5, 6, 7. So over here we would have X, and then there's a positive 7, so that'd be X plus 7. So if you're looking over here, you're thinking, oh, X plus 7, X plus 7. So one of these two must be the correct answer, because it says, which equation does the set of algebra tiles represent? Well, this is X plus 8, and that's X plus 8. And we see that there are 7 of them over there, so it's one of these two. And you're probably looking ahead right now thinking, already counting these over here. So I could sit and count them, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay, here's the correct answer right here, 16. Or instead of counting all of them, I could have realized that I have 3 this way, and then I have 5 this way, and 3 times 5 is equal to 15, and then I've got one more. So 15 plus 1 is going to equal 16. So you could count through them, or you could do it in what we call an array, columns across the top, and the number of rows, multiply that 3 by 5, and then add whatever's there. So a little bit quicker way of counting these algebra tiles. However, let me go on. I was going to state that the other side, the positive color for the units, is like this yellow or this tan color. And there is if you flip them over, they are indeed red. So we could actually solve this problem using algebra tiles. Now, the thing about it is that if we put together a positive, such as this one here, we got this positive here, and then if I flipped it over and I had red on the other side, the value of the positive one and the negative one together would equal 0. And this is what we call a zero pair, because they're a pair of numbers, 1 and negative 1, that have a value of 0. So if we had these and we were in class and we were using them, the question would be, well, how would you use algebra to solve this? How would you find out? Because the object is, we want to know what is the value of just one X, right? And so we're going to get to where X equals some number here. Well, you could say, well, what I do to one side, I do to the other. So why can't I just take away these 7 here, right? Pull those away to where I just have the X, and then let's take away 7 here as well. And that would be 7 of them right there. And we take those away. That leaves us with, well, 3 by 3. It's going to be 9. So X equals 9. Another way to do that is, instead of just removing the positive ones, technically, whenever we do this problem, right, if I were to explain this problem right here, I would say X plus 7 equals 16. Now, the inverse operation of addition is subtraction, so I'm going to subtract the number I want to get rid of, and what I do to one side, I do to the other, right? Now, the way that looks with algebra tiles is we're adding a negative 7. So over here, I would actually be adding 1, 2, 3, 4, 5, 6, 7 negatives. So I'd be adding -7 to that side. And what I do to one side, I do to the other. 1, 2, 3, 4, 5, 6, 7. Glad I don't have to add a negative like 20. I'd be here drawing forever, right? So I think I got 7 there. 3, 4, yep. And then we'd start making 0 pairs. We could pair them up and pull them away. Here's 1 0 pair. So those cancel each other. This cancels that. This cancels that. This cancels that. This one cancels this one. This one could cancel that one. This one could cancel that one. And then we'd have nothing left over here except for the x. Then on the right, we'd be making 0 pairs. Those cancel each other. There's a cancellation there. Those cancel each other. This cancels that. This cancels that. This cancels that. And this would cancel that. So we'd end up taking away all of this here, right? And then we'd also be taking away all of this over here. And then all we'd have shown would be x equals 9. So you'd end up seeing just this x. You'd have the 9 units there. So that's how we would use algebra tiles if we were in the classroom. This particular problem asks us to not solve, but to go ahead and show which equation represents the set of algebra tiles here. So in this case, we're just looking for which one that it represents. However, I did want to take the opportunity and the time to explain what algebra tiles are exactly. What do you use them for? It could get real easy just counting and putting things together and matching up the right one. So with that said, let's go ahead and look here. Which set of algebra tiles represents x plus 9 equals 16? So here's the equal sign here. So we're looking for x plus 9 on the left. Well, here's x plus, looks like, 6, 8. That one doesn't work. That's x plus 3. There's x plus 2. It must be this one here, right? I really don't have to go any further, but I could check. Is there 16 on the right? Well, 3 by 5 is 15, plus the one more is going to give us 16. So indeed, there's 16 on the left. So the correct answer is the last one. Which equation does this set of algebra tiles represent? Well, this time we have 1, 2, 3, 4 x's. So we should be looking for 4x on the left. That's 2x. Here's 4x, 4x, and 2x. So we can rule out the first one and the last one. So both of these are 4x, so either one could be the correct answer. Now it looks like we have 3 by 2 is 6 plus 2 more is going to be 8 altogether. So it should be this one here, 4x equals 8. Which equation does this set of algebra tiles represent? Well, we have, again, 1, 2, 3, 4 x's. So 2x won't work, 2x won't work. It's one of these last two here. And then over here I have 4 units, so it should be 4. And it looks like I'm looking for 4x plus 4, or 4x equals 4, which is right there. So this one here we rule out. What equation does this set of algebra tiles represent? So now we have to write the equation out. So combine like terms on each side of the equation. For example, write 3 instead of 1 plus 1 plus 1. Well, how many x's do we have here? I kind of like my eyes, I catch these in groups of 3. I think 3, 6, 9. So there's 9 x's, so I'll put 9x, the equal sign, and then 3 by 3 equals 9. So I have 9 x's equals 9. What equation does this set of algebra tiles represent? Well, I have 1x, so I'll put the x there. I have 3 by 3 on this, so there's going to be 9 units there, so they're positive 9, so x plus 9. And then my equal sign. And then this one here, I have 3 by 4, so that's going to be 12, right? Plus these two out here is going to give me 14, right? So I end up having 14. And this one here says use algebra tiles to solve x plus 4 equals 7. So I could just take away 4, right, from each side. I got 4 of them here, so let's cancel 4 of those. And let's cancel 4 of these. And we see that we have 1, 2, 3, so x equals 3. Now, technically, the way to do it would be to make 0 pairs. So I have x is tied to the 4 through addition, so I need to subtract. I'm going to subtract 4. So I'd have to add 4 negatives to each side because I have 4 positives with the x. 1, 2, 3, 4. And what I do to one side, I have to do to the other. 1, 2, 3, 4. So I would add 4 negatives to each side. Now these cancel, those cancel, those cancel, and those cancel. And cancel that, cancel that, cancel that, and cancel that. What would you have left? You'd have 3. All right. Last one here. What equation does this set of algebra tiles represent? Well, I have 3 x's here, right? So I have 3x, the equal sign, and then I have 3 by, looks like 5 across here, right? Yep, 3 by 5. 3 times 5 is 15, so equals 15. Now, if you were to solve this, how you would solve this would be a division problem here. And we really haven't covered solving using addition or using a multiplication or we haven't really started using multiplication or division yet to solve one-step equations. But the way that it would work is you only want to know the value of 1x. Whenever we get a solution, we have x equals. We want to know just the value of 1x. So we would have to divide this into 3 equal groups, right? We want to know just for 1x. In order to see just 1x, we had to divide it into 3 equal groups. So we would have to do the same here and divide this into 3 equal groups as well. And since they're in 3 rows, it makes it really convenient. And now we can see that 1x, what 1x equals, each one of these x's could be assigned to a, this one here to the middle, be assigned to a set that's been divided equally. So we divided the left equally by 3. We're going to divide everything on the right equally by 3. And we end up with 1, 2, 3, 4, 5. X equals 5. And we can check the solution by substituting it back in. So 3x equals 15. Let's go ahead and substitute for the value of x. We're going to substitute 5. 3 times 5 is 15. Does that equal 15? Indeed, they equal each other, so it does check out. All right. So that is my lesson on algebra tiles. Lesson 6.Z.5, model and solve equations using algebra tiles. Good luck with your activity.